Okay, so we did the graph where we graphed circumference versus diameter. Okay, and I've unfortunately erased the graph from yesterday, so I don't have it here. Okay, but I think everybody probably got a slope that was close to 3.14. If you haven't finished that graph yet, please finish it first. Draw your best fit line, calculate the slope, and remember, okay, we do that by drawing hopefully a straight line, all right, of our points, and then looking for grid intersections, okay, along the line, like this one here and that one there, okay, and then we go across and we get y2 and we get, okay, y1, okay, this is x1 down here, okay, and this one's x value would be x2, right, and so on and so on, right? I'd like you to do that for that graph because we know what the slope should come out to on that graph. It should be 3.14. I think I got 3.42 with you guys. I got 3.13 in period 3. Okay, it's just to prove to you that I can do it. All right, I did get 3.13 yesterday. All right, so that's what we want to do. Just practice that, and then you've got two other graphs. Okay, two other sets of data there. I would like those two things to be graphed. We have a short class today, so if we get done those two graphs, you can start looking at the slope calculations on the graphs that are made for you on the next sheet, okay? And if we're having trouble, we'll go through them together, all right? And I will quickly draw up those other graphs as well, all right, in a few minutes after you've had a chance to do them, and you can compare your answer for your slope to mine, all right, and see kind of how you're doing there. All right, so that's the plan for today, just kind of a quick practice period on graphing, because on Monday, we're going to do the lab. Okay, where we're going to run the carts down the hallway and record their positions at various times, and then we'll graph some real data. Okay, and we'll try and calculate their average speed as they travel down the hall. Yeah, I have those little dollar store motorized carts. They crawl along very slowly. They're not fast. No, not shopping carts. No. Yeah, there's that whole people get hurt, I get sued and lose my house thing about that. So yeah, okay. No, you can't just say no, it's all right. You can't even sign a waiver. Okay, sorry guys, quick note here on number 2, because sometimes it's hard to tell which is the manipulated and which is the responding variable. All right, which variable goes on the x-axis? Quick review. The manipulated variable. Okay, in an experiment like this, okay, they're wanting you to plot a graph of length versus force for the following experiment done on an elastic band, and then they don't tell you how the experiment worked. Well, if they don't tell you how the experiment worked, it's hard to figure out which was the manipulated variable. In this case, the experiment is working like this. Okay, they are applying, okay, they are measuring the force needed to stretch an elastic band. All right, so they are picking the distances to which they stretch the elastic band and measuring the force, recording the force required to do that. All right, so in that case, what are they manipulating? The length of the elastic band. Okay, the length of the elastic band here is the manipulated variable. All right, it doesn't really matter which way you do it because the experiment could go either way, and I actually have the slope on here for either way. Okay, but let's just say for argument's sake that we're saying they chose the distances and measured the resulting forces. All right. Okay, if we were looking at this graph as being a test question where you were asked to construct the graph and calculate the slope, I would say I would probably accept somewhere between 0.44 and 0.52. Okay, somewhere in there as an acceptable range for slopes. Okay, that gives a fairly wide range, okay, of acceptable best fit lines. Okay. Now, quick question here in terms of interpreting the graph. You'll notice the best fit line on this one does not go through the origin. Okay, any reasons why it wouldn't go through the origin? John? Right. A rubber band has length when you're not stretching it, agreed? What is the length of this rubber band when it's not being stretched? 6.5 centimeters. All right, and you can see that down here, that our first point is actually at 6.5 on the x and 0 on the y. All right, and so that's showing us there that we don't need to start our best fit line at the origin because it would be impossible to accurately follow the trend of the points if we did so. All right, so remember, your best fit line does not always need to start at the origin. All right, your best fit line needs to start wherever you think it needs to start in order to best follow the trend of your points. All right, there's no hard or fast rule, okay, on that. We're giving kind of you the freedom to decide where you think it needs to go, because that is more often than not going to be the most accurate way. Mac. Yes, yeah. That's what we said at the beginning, right? We said we're going to say that they picked lengths and measured the forces at those lengths, right? We'll say, yeah, if you did it the other way, you would have got somewhere around here, okay, 2.1. So let's say between, what, let's say 2.8 and 2.3, okay, 2.4. Yeah, so you're good. Okay, how many people are on to the third one? All right. I'll leave this one up for a few more minutes so you can check it as you go, and then I'll put the third one up. Okay, guys, so for number 3 here, okay, I have that one backwards. Ignore that one. I'm going to redo that one here in just a sec. For number 3, we should have, that's not the one I want. Okay, for number 3, what's going to be the manipulated variable in number 3? Yeah, the number of sheets. The number of sheets in a book is what determines the book's thickness. Agreed? Okay, the book is thicker because it has more sheets. So we're manipulating the number of sheets to see what effect that will have on the thickness of the book. So the number of sheets, okay, should come down to, or should be on the bottom, on the x-axis. All right, so I will quickly redo that one here. Right. 3.3. For this graph, for graph number 2, okay, the thing you have to realize here is where you draw your best fit line. Once you have your points plotted, okay, make sure your best fit line follows their trend. Does a best fit line always have to start at the origin? Yes. No. Okay, a best fit line does not always need to start at the origin. It should start wherever it needs to follow the trend of your points. Okay, everybody follow me there? All right, that's the rule you need to remember about best fit lines. They can start wherever you need them to start. That gives you the freedom, okay, to make that best fit line have the slope it needs to have. Okay? Now, other things to remember. How do you decide what your scale is? Right, highest number you have to fit on that axis divided by the number of squares available on that axis. That will tell you what number. If it's a decimal, what do you do with it? Round up. Doesn't matter what the decimal is, round up. All right, that way you will make sure it fits on there. Do you have to round up to the next nearest number, or can you round to a convenient number? Okay, you can round to a convenient number as long as it's still going to be 80% of the graph paper. All right, so I'll give you a little bit of time on that, and then I'll do that graph so that we can compare. Okay. Okay, so if you're working on number 2, remember your scale is going to be slightly different than mine because your graph paper is a different size. Okay, and I want you to do yours according to what you have on your graph paper. Okay, but remember that length we're saying is the responding variable, force, okay, is the manipulated variable, so it goes on the x-axis. Okay, and once you've got everything done, okay, remember you figure out your scale by dividing your biggest number by the number of spaces, okay, and so that's already been done. The scale's already been put on. Okay, next thing to do is plot the points, so we'll do that and then we'll draw best fit line. Okay, so on this one here, guys, now that we've got the points plotted, okay, we got to draw the best fit line, and it obviously should not start where? It shouldn't start at the origin. My first point is on the y-axis at 6.5 centimeters. Okay, so I should probably start somewhere around there as best I can to follow the trend of my points. Okay, so okay, probably something like that. I know that sometimes in math they teach you that the rule for drawing your best fit lines, you should have the same number of points above and below the line. And while that's a pretty good guideline, I don't like it as a rule. Okay, but it's an okay guideline. You're not always going to get equal numbers above and below, but okay, if you're close. Okay, and we've got two above, two below, a couple that are kind of on there. Okay, so I think we'll keep that one and we'll look for the grid line intersections. Okay, looks like a good one right there, and another good one right here. Okay, so we'll use those two for our slope calculation. Okay, so slope is going to be y2 minus y1 over x2 minus x1, and y2 is 28. x2 is 10.8. And y1 is 14.2. 14.4, sorry. 14.4. And 4.2. Whoops, did that wrong. 14. Ah. Two can play that game. Okay, so that's what our slope calculation should look like. All right, when we punch that into the calculator, okay, we'll get brackets 28 minus 14.4 divided by 10.8 divided by, or sorry, minus, no, divided, minus 4.2. Okay, we're getting 2.06. So well, we'll write 2.06, but 2.06, and what are my units going to be? Y is in centimeters, and X is in newtons. What are my units going to be? Centimeters per newton. All right, so for every 2 centimeters you stretch the rubber band, you will have to apply how much force? Roughly? Yeah, something like that. Okay, for every 2.06 newtons you apply, or sorry, for every 2.06 centimeters you stretch the rubber band, you'll have to apply 1 newton of force, is what that's saying. All right, so if you flip it the other way, it's about, what, 0.5, something like that. All right. Okay, so a couple of other things that this question asks us to do, and if you've done this in math already, it might make sense. If you haven't done Math 10 yet, it probably won't. All right, they ask you about the y-intercept and the equation of the line. Okay, the y-intercept is just like it sounds. Okay, intercept means to cross, meet, okay, somewhere. So the y-intercept is where your best fit line crosses or meets the y-axis. Okay, and that happens right here at 6.5 centimeters. All right, now, what does that number represent? When is the rubber band 6.5 centimeters long? When there's no force acting on it. Okay, it is the unstretched length of the rubber band. That's why your best fit line can't go through 0. If your best fit line went through 0, you would be saying that your rubber band doesn't exist when there is no force acting on it because its length is 0. I don't know any rubber bands with a length of 0. All right, everybody follow me there? Okay, now what it means by the equation of the line is we can sometimes do this. Y equals mx plus b. That is the line equation or the graphing equation. Okay, y represents any y value. X represents the corresponding x value. All right, so if I pick any point on the best fit line, I need the y and x values of it. So 0 would be the x for this point, 6.5 would be the y for it. Okay, m is the slope, okay, and b is the y-intercept. Right? The reason you have that equation is because you can extrapolate, which means calculate mathematically information that doesn't appear on the graph. All right, so if you wanted to go beyond what the graph showed you or beyond what your data said, you could figure out how many newtons it would take to stretch the rubber band 1.5 meters, okay, if you wanted to. All right, we don't do that much in Science 10, but that's what they mean by equation of the line. They mean write this out. Okay, we're not going to have to do that, but just for interest's sake, that's what it looks like. All right, questions there? Okay, how many people have done that graph? Okay. When you're done, compare your slope to this. I would say let's make the range of acceptable slopes between 1.8 and 2.2. Okay, if your slope falls between those numbers, you drew a pretty good best fit line. All right, if you're slightly outside of that, you're either a little bit too steep, a little bit too shallow. Okay, if you get 4, you did something wrong. Alrighty. Okay, keep going on that, guys. Okay, so you don't have to, I mean, you can check this when you get to this point, but I'll get you the slope here for the third one so you can compare your numbers as well. Okay, so we'll have 18 minus 6.6. Okay, so we should get somewhere around 0.15 millimeters per sheet. Okay, for the slope for the third one, I would say acceptable range would probably be somewhere between 0.11 to 0.19 millimeters per sheet.